Welcome to another video. Today we're going to have a look at function tangents and normals. I'll explain what those are, and what we're going to do is be finding the equations of these things. Okay, so let's have a look. Let's say we've got a function y equals f of x there. So y equals f of x, that red line there. And so what a tangent line is, and I've already sort of used this language, but if you have a point somewhere there, right? So my green point I'll just put on there. Then the tangent is a tangent line. The definition of it is a line that only touches the line once, so it can't sort of cross over like that. That hits the line twice, that green line there. But if I draw a line that perfectly only touches it once, it goes through like that. What we call that is called a tangent line. Okay, tangent line comes off and it just perfectly hits that point, the red line once. We call that a tangent line. And that tangent line gives us the gradient at that exact point. Okay, so let's say if that was -2, if x is equal to -2, the gradient when x is equal to -2 is the same as the gradient of that tangent line. Okay, so that's what we mean by a tangent line. And what do we mean by a normal line? Well, the normal is the exact perpendicular line to that. So I'm going to draw it. It's going to be bad. Oh, that was pretty bad. Let's try that again. And so that line there, if that's 90 degrees from the tangent line, then we call that black line there the normal. Okay, so the normal is exactly 90 degrees to the tangent, so it comes through at that exact point. Okay, so hopefully that sort of makes sense what the tangent line is and what the normal line is. A few little points before we get into nitty gritty. But if you're ever trying to find the angle, okay, so the angle theta, just in a bit of color, angle theta there. If you're trying to find the angle that a line makes with the x-axis, so I'll just draw it here. I'm going to run out of colors a little bit. But what color can I use here? I've used everything. I'm going to have to go back to blue. I'll use that. So if I draw a dotted line through there, that's supposed to be a horizontal line, then that angle there from the tangent there, that is angle theta coming around to there. So we call that the angle of inclination, about how much it's gone up, and eventually it's the angle that it makes with the x-axis, because if you think about it, that angle is the same as that angle there. Okay, so that angle tucked in there, the angle it makes with the x-axis is calculated by using this m equals tan theta here. Okay, so if you think about that, you'll see why that works. But m is equal to tan theta. If you think about rise over run, that's how we calculate the angle of inclination. Or sometimes in exams they'll ask for the angle that it makes, the tangent line makes with the x-axis, something like that. Okay, the second thing we need to know is this here, that if two lines are perpendicular, then when we multiply together their gradients, we get -1. What that means is if you're trying to find the gradient of the normal, that will be equal to -1 divided by the gradient of the tangent. Okay, so just keep that in mind. Remember that. When we're trying to calculate gradients of tangents, etc., and gradients of normals. The other thing to remember is this point here, that when you've got the point, I'm just going to hopefully remember this from linear graphs, that if you've got a gradient with line, say 2, a gradient of 2, and it goes through point, I don't know, 4, 7, something like that, then what we can do, that there is x1, y1, x1, y1 going through that point, then we can quickly write down what the equation of the line is. It will be y minus y1, so y minus 7 is equal to the gradient 2, and then x minus x1, so x minus x1 is 4. So we can quickly write down an equation of a line, and that helps us to sort of quickly get there rather than substituting the point back into the equation, y equals mx plus c. You can sort of quickly get to the y is equal to 2x. It's going to be 2x take away 8 negative, so it's going to be take away 8 plus 7, so it's -1. So you just quickly get to the answer there. So hopefully you remember that back from linear graphs, because we're going to use that a little bit today in finding the equations for tangents and normals. Speaking of which, let's do it. Okay, so in this question, we need to find the equation of the tangent and the normal. So we need to find two different equations for f of x is equal to x cubed, take away 2x squared plus 5 at the point x equals to 2. Okay, I don't even know what this thing looks like. It's a positive cubic, so I've got a general idea, but I don't really need to know much about what it looks like to calculate this. So my first step is, because I want tangents and normals, I need gradients. To find gradients, I need the gradient function, otherwise known as the derivative. Okay, so f dash of x is equal to 3x squared take away 4x. There's my derivative function. Fantastic. So the gradient of the tangent is going to be equal to f dashed of 2, okay? The derivative when x equals 2 will tell me what the gradient of the tangent is equal to, like we discussed before. So I just substitute in x equals 2 into my function, and I get 3, 2 squared, take away 4, 2. 2 squared is 4, 3 times 4 is 12, so that's 12, take away 8. So I get my gradient of my tangent is equal to 4. Okay, the other thing I need to know to be able to find the equation of the tangent is I need to know the point, and so f of 2, so also f of 2, if I substitute 2 into my function, I get 2 cubed take away 2 squared plus 5. 2 cubed is 8. Take away 2 times 4 is minus 8 plus 5. So that's equal to 5. And so that means it goes through the point 2, 5. Okay. So what we've got here, remember, we've got our gradient. Our gradient is 4. Okay, so I'll just write it here as a reminder. M is equal to 4 for the tangent. This is the tangent we're doing at the moment. Okay, we're finding the equation of the tangent. M is equal to 4, and it goes through this point here, and so that's my x1, y1. Okay, so therefore we've got y take away 5 is equal to 4x take away 2. Okay, and just to sort this out a little bit, y is equal to, it's going to be 4x, and that's going to be 4x take away 8. That seems what I did before. 4x take away 8, it's going to be minus 8 plus 5, so that's going to be minus 3. So that is the equation of the tangent there, okay? So I'll just label there. So that's the equation of the tangent. That's done. Secondly, now I'll do it in a different color so that it doesn't look confusing. In fact, I just changed colors there. So let's do now the normal. Okay, so let's do the normal. And so the normal, what we need to do, again, we need to know the gradient. So the gradient will be, I want to do it in green and try to stay consistent. So the gradient of the normal is equal to -1 over gradient of the tangent. Okay, so that's what we talked about at the start today. That's this here, that the gradient of the normal was equal to -1 over the gradient of the tangent. So now we're going to be trying to find that. Oh, I'm going to run out of space here. I've taken up too much room. I'm confident I can get this done. So that's -1 over the gradient of the tangent. And the gradient of the tangent was 4. So it's going to be -1/4. Okay, so there's my gradient of the normal. It also goes through the point 2, 5, okay, because it still goes through the same point. If you remember that there, the tangent and the normal both go through that same point. So, so they both go through 2 and 5. And so we can go straight to writing down what our equation is. So it's going to be y take away 5 is equal to the gradient, -1/4 x take away 2. Okay, and just to clean that up a little bit, let's clean. I'll take this one a little bit slower because it's got a fraction in it. So I've got y is equal to, if I expand that out, it's -1/4 x plus 2 times quarter, so that would be plus half. Okay, and then plus 5, bringing that -5 over to the other side. And so my final equation is, oh, that's horrible, therefore, y is equal to -1 quarter x. Positive half plus 5. 5 is 10 over 2. 10 over 2 plus 1 over 2 is plus 11 over 2. And so that's the equation of the normal. So I've figured out the equation of the tangent up here. That is my equation of the tangent, and that is my equation of the normal. And that sort of makes sense if you think about it. The tangent has a gradient of 4, if you like, so it's really steep. And the gradient of the tangent is -1/4, so it's sort of like slope that goes down like that. So they would be perpendicular to each other. That sort of makes sense. Last bit here, hence find the angle the tangent makes with the x-axis. Okay, so we want to know what the angle it makes. So here we've got m is equal to tan theta. Therefore, what was m? For our tangent line had a gradient of 4. So 4 is equal to tan theta. Therefore, theta is equal to arctan, or inverse tan, of 4. Go to my trusty calculator. Where is it? Here. And so I want inverse tan of 4 equals, I'm in radians mode at the moment, so I need to change that to degrees. I'm going to click on the book, use my trust. This is the only thing I ever use the book for, the DD function. That changes it to decimals. Sorry, not decimals, to degrees. That's obviously exact, so I'm going to press Control equals, and I get 75.96 degrees. 75.96 degrees. I was a bit lazy in my question. I didn't say in degrees or in decimal places, but you get the idea about how you'd find the angle that it makes with the x-axis. Hope that makes sense. See you in the next video.